Hello, everybody, and welcome to Honeybee Watch Symposia series. I'm Steve Rogenstein. I'm your host, behind-the-scenes producer, and Honeybee Watch's project director. And I'm joined by my colleague, Rodrigo Moro, who is Honeybee Watch's science director. As I said, we have more than 150 registrants, and hopefully more people will sign in as we progress. So today we're super excited because we're departing from our usual focus on honeybees. And instead, today our protagonist will be tree cavities. And we have three experts with us who work predominantly with them, and they will share their expertise and their anecdotes. So in the interest of time, because we have lots of material to cover, I'm just going to give a very brief introduction to Honeybee Watch. We are an international coalition tasked with better understanding how and why free-living honeybees survive via natural selection with little to no human intervention. We've been around for about 4 years, and in that time, our research partners and participating citizen scientists have identified more than 2,000 nest sites on 5 continents. So it's super exciting for us. We haven't done that much communications or promotions. It's a full volunteer group, so it's pretty astounding what we've accomplished so far. We are working with the International Union for the Conservation of Nature, IUCN, to reassess the red list status of Apis mellifera in Europe, which we're very proud of. And amongst other activities, including this Symposia series, we're applying for grants to fund our study. We're striving to expand into Africa, the Caribbean, Middle East, and beyond. I believe a couple of people from Kenya are going to be here with us today. So if you have any potential leads for us for sponsors and or funders and or opportunities for us to establish a regional cell where you're located, please get in touch. And if you'd like to know more about Honeybee Watch, there's an 8-minute presentation on our resources page of the website. And it's the first video. And Rodrigo, if you could just drop, there you go. That's the link to see our resources page. And there you will find all of the videos that we've uploaded from past symposia and other events, as well as articles, videos, publications, reference points, etc., about free-living honeybees and related topics. So we are expanding that page, and it's super interesting if you want to do a deep dive. So a little bit about the Symposia series. We launched it last year with several objectives, and the first and foremost is to build this international coalition and grow our network by bringing experts together, such as Kevin, Mick, and Barbara, to introduce them to one another for potential future collaboration, introduce you to them and their topics, and bring you together in a forum where you can see each other, interact via the chat, connect otherwise in the future if you'd like, because it's really important for us to bring everybody together. And also for us to provide this platform whereby we can hear these different perspectives and the expertise and experiences of our guests. And of course, to discuss these individual issues, such as today, tree cavities, and hopefully progress on topics that we've been challenged by at Honeybee Watch, and many of our research partners up until this point have dealt with these issues as well. And that brings us today to today's symposium, which is titled Tree Cavities, Homes and Biomes for Bees and Other Organisms. And as I intimated, it's a departure from prior symposia, with the star not being honeybees, but rather tree cavities. And in case that's not self-evident, these are natural hollows in trees by which a diverse array of species is often involved in both their formation as well as in their habitation. And there have been found birds, invertebrates, small mammals, fungi, and more, and we will hear some of those stories today. From our three experts who come from various fields and have explored the topic of tree cavities from different perspectives. And because they are coming together, we're going to hopefully give a more holistic view into this fascinating biome and this natural bee habitat. I'm going to introduce our first guest because I want to give them more time rather than me. So our first guest is Kevin Smith. Kevin has been researching trees, specifically energy flow, defense processes, and the causes and effects of wood decay for more than 40 years. He's particularly fascinated by trees' responses to injury, infection, and environmental change as caused by fire, storms, acid rain, for instance, fungi, human activity, and more. He works at the USDA, that's the United States Department of Agriculture, in the Forest Service Department on the East Coast of the United States, and has published more than 150 research papers. We found him kind of randomly, I must admit, via Google and other searches. But when Mick was the first speaker to agree to talk about bees and trees, we brainstormed as to who we'd like to hear from and engage with in conversation. And he mentioned Dr. Alex Shigo, who is the discoverer of tree compartmentalization, which is a topic that Kevin will explain later. And when I started researching others who are connected to Dr. Shigo, yes, Kevin's name was one of the first to pop up because he's been a collaborator, he was co-author, colleague, and a friend of Alex's, who sadly has passed away. And when I wrote to Kevin and presented the concept of this symposium, he agreed to participate, and here he is today. So we have your presentation loaded. I will give you 13 minutes on my clock and give you a 1-minute warning. So apologies in advance for any interruptions. Would you like to unmute yourself?
Yes, please. So Kevin
Super.
Smith, thank you everybody for being here. And yes, it's a real pleasure. I have been studying how trees deal with injury and decay for, as I was saying, 40 years or more. And so today, I'm really happy to present a little sketch of cavity formation. And I did put my website address in the chat for links to more of what I do. And
And I'm going to interrupt just a little bit. Because English is not Basha's first language, what I forgot to mention is if we could go slowly and clearly, just so she understands everything. Thank you.
very good, thank you. And so what I really want to use my time for is how do we even think about cavities in trees? I mean, they've been inspiration for artists, and Dutch master painting on the left there, and people. Part of the attraction of that artwork are the cavities there in that standing tree, and that's a beautiful thing. What's funny to me is that if we look at the tree photo on the right, where there is a cavity from a branch stub and other probably cavities in formation, I also see new sprouts growing up around the wound wood, which is that tissue, that wood tissue, which is tending to close over the wound. Yet when we see this in urban trees or street trees, people get concerned and upset that, well, the trees are sick. However, trees are able to deal with injury and infection as well as cavities and can deal with it pretty well. And that's what we'll be talking about here. Historically, as I say, I worked for the US Department of Agriculture in the Forest Service. Historically, interest in cavities and in wood decay in living trees purely concerned the lost value of timber, the volume, wood volume, or wood quality. And here with a little cavity on a yellow birch, and that is from a codominant stem that had died and has decayed. And Current research and forest management favors the retention of trees like these. So in the old days, this was looked at negatively because of the loss of productivity. But for me, we're now looking at this as another part of the biodiversity and just what allows the biodiversity in our habitat, in our planet. Another thing that I do with tree injury is use it for various dendrochronological purposes, that is to say, the timing of events. And so the scarring and cavities can help provide information on fire history and environmental change. So what I'm trying to say is that what we're interested in here today of cavities and honeybees is part of this much larger interconnection of nature and the environment. Now, historically, when you would talk about, I am a forest pathologist, which means I work with tree diseases. Historically, when people saw cavities in street trees, yes, they wanted to do something about it. They wanted to fill the cavities up. And several generations of good, smart people misuse their time in filling up these cavities. That's an editorial on my part, take it or leave. So that's what historically what cavity treatments meant. The take-home message. This is what I would like you to be able to leave my part of the program, is that natural cavities form from the interaction of wood decay fungi with the protection and defensive processes in living trees. It takes both. It takes both the wood decay fungi and the interaction of these defense processes in trees that yields a cavity. If you think of a board rotting on my porch outside, I'm at my home now, you don't see cavity formation. I mean, you'll see decay go from one end of the board to another, or maybe starting in the middle, but it's not cavity formation. The fact that we get cavities comes from those defensive processes in the tree. Trees teach us various things, including some of the importance of wood decay in the life of trees. Wood decay processes greatly benefit the tree by decaying wood on branches which are no longer needed. So here are two trees, both with wood decay fungi, and you see, where does the wood decay fungi stop? They stop right at the base of the branch collar. They don't go into the recently formed stem wood. And this is how wood decay helps trees shed branches, which they need to do during their development. So this is an example of decay being good. On the inside of the tree, here on the left, there is a branch that had been shaded out. This is an American beech. And the branch died, and the protective processes in the tree are attenuating or reducing the effects of the wood decay here. So there's decay fungi here, 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 all down here, and then are stocked at the base of the branch. And in an artist's conception, which is correct, here we can see that dead branch. We see a growth stimulation around the branch and the decay occurring within the stem. So diagrammatically, this is where most of the, not all, but most of the cavities that I find in trees that would support bees are from branch stubs. Here is an example of an improperly pruned branch where there's stub was left. You see the tree is growing quite assertively in its producing wound wood to close over the branch, but because this is in here, it can't close and seal off the wound. So it's this process which yields the cavities. Now, most of the people I talk to want to reduce the number of cavities, not increase the number of cavities. But if you are interested in increasing, stub cutting, leaving a stub in a branch pruning would work, or cutting branches flush with the stem. I hasten to say this is not good practice for urban and community tree care, but it may be what you could do in promoting the formation of cavities. And here, just again, artist's conception. On the left, we see a top that had broken out of a tree and a branch or a codominant stem taking over here. These colors are just sort of diagrammatic that the changes occur in successions, and we don't really have the time to go into the details on that, but that the tree, the take-home message, the important thing for us here is that the tree is responding actively to the wound and to the infection processes. Another way we find cavities in trees is from basal injuries, wounds at the base of trees, particularly at roadways or trails, and that also leads to decay within the center of the tree. Here, this is walking distance from my house. The thing that people see first here is this big wound. But I am more interested in this very thick wound wood, which is actively promoted. It's a growth stimulation that's working on closing the wound, and closure helps the tree continue its life processes. Here we have on the this yellow birch to this side, we have a wound that was made some years ago, and I made this with a hatchet, and we see the ribs of wound wood closing over the wound and decay occurring behind the wound. And not only is it wood decay, and this is something you guys, if you want tree cavities, you want wood decay. Here we have different wood decay fungi that are even forming zone lines in the decayed wood. And what these lines, this spalting indicates different genetic individuals of decay fungi interacting with each other. So compartmentalization is I'll say merely, is merely a way to conceptually model what happens when trees are injured and infected. And it's a conceptual framework for how trees grow and defend themselves. And that's a picture of Alex there in the 70s. And part of what compartmentalization is about, quick little sketch, is within wood, when the way wood is formed, there are various potential and actual boundaries that resist the spread of decay. So the tree is trying to minimize the decay while the decay fungi are trying to maximize the decay. What we see as a cavity is a snapshot in time of the balance or equilibrium between the tree defense and the wood decay fungi. And Alex and I, yes, we're on the road talking about this for quite a while. And just as what these boundaries that I had talked about, here's a little picture. This is a section from a red maple that I had drilled a year before cutting the tree and taking this disc out. And what we, so the borehole here is an inch or two away from what we're seeing here with the shadow. All I'm trying to show here is how rigidly the tree is responding to this borehole to produce waterproofing compounds and chemicals to keep the infection here and keep it from spreading this way or outward to the vascular cambium. And that's what this barrier zone that is formed after wounding. This is part of compartmentalization. and see how nice and clean and uninfected that new wood is. And the growth is stimulated by the proximity of that wound hole. So these are the patterns you'll see. How do decay fungi get into the tree? Storms, fire, PPD is sort of funny, but it's people pressure disease. Human interactions with trees often result in wounding. Branch stubs, like we saw. Also, root decay can cause cavities in the center of trees. This is also in my neighborhood. I did not put the please do not disturb the mushrooms up, but somebody did, one neighbor did. So there are woody roots here, and the woody roots are supporting the growth of this fungus, which is, and it's making its mushrooms here, but it is growing into the wood as well. So this is another way of how do the decay fungi get in. The sulfur shelf, a common edible fungus here and in Europe, and that can also produce good cavities. This is a North American fungus that also produces good cavities. And when I say good cavities, what do I mean? I mean cavities, but that the tree responds and produces a strong, healthy tree around the cavities. And this is what permits the cavities to exist for years or decades. Are those defense processes balancing out the effect of decay? Okay.
Kevin, I just want to give you the 1 minute.
Thank you. The quick thing about animals, and I'm sure it'll come up, woodpeckers, beetles, other critters. Our story is that the impact of the animals is only on wood that's already in the decay process. So when the woodpeckers do excavate, but they're excavating decaying wood. Carpenter ants do excavate, but they're excavating decaying wood. So the point isn't the animals, it's the decay. That's my point of view. Take it or leave it. And that's what the carpenter ant story is. If you look at this, any insect person would say, carpenter ants are making that cavity. No, carpenter ants are just cleaning out the stuff. They're in the cleanup crew, and it's the wood decay fungi which are actually breaking it down. And we can get all sorts of crazy things. If you look on my webpage, publication page, and look for skeleton decay, you'll hear the explanation of how did this cavity happen. Okay, that's enough out of me. Please, I'll share the time. I've spoken more than I've needed. I will stop the sharing and pop out here.
Well, I'm really sorry that we had to interrupt you because it was getting very fascinating. Thank you for that introduction to tree cavities. I love that it starts with you, with how they form and what the trees do to create these defense systems. You started mentioning carpenter ants, and I know a lot of people curse carpenter bees because not only are they going into trees, but they're going into people's fences or in the side of their homes. But interesting that it's only when there is already existing decay. So don't curse your bees. It's the fungi probably that's causing it. So thank you very much, Kevin.